In an acid-base titration experiment, 23.40 cm³ of 0.106 mol per dm cube triazonitrate 5 acid completely neutralized 20.00 cm³ of calcium hydroxide. Calculate the molar concentration of the basic solution. From the question, you are being made to understand that the reaction between the acid and the base here is a neutralization reaction, as we all know. So the first thing to do is to write out the chemical equation showing the reaction between the acid and the base. So we have the acid to be triazonitrate 5 acid, which is HNO3. Reacting with the base, calcium hydroxide, so here the salt will be calcium nitrate and water. After writing the chemical equation, the next thing to do is to balance the equation. So let's start with the base. We have two. For the base now, we have one atom of calcium present in the reactant side, and in the product side we have one as well. For oxygen here, these two will be used to multiply whatever is in the bracket here. So we have 2 here plus 3, that's 5. So let's check here. We have 2 times 3, that's 6. We have 6 atoms present in the product side. So oxygen is yet to be balanced. To balance oxygen, let's add 2 as a coefficient to the acid. Now we have 2 times 3, that's 6, plus 2 here, that's 8. We have 8 in the reactant side, and in the product side we have 6 plus 1, that's 7. Is yet to be balanced. So we'll be adding 2 here as well. So this makes it 6 plus 2, that's 8. So the oxygen atom is now balanced. Let's move to hydrogen. Hydrogen here is 2. Then we have 2 here, that makes it 4. So here we have 2 times 2, 4 as well. For nitrogen, we have 2 atoms of nitrogen present in the reactant side. In the product side, 2 times 1, 2, we have 2 as well. We've checked oxygen earlier, oxygen is balanced. So we can say we have a balanced chemical equation. So now with the balanced chemical equation, we can proceed with the formula. The formula we'll be using to solve this is CnVa over CbVb, which is equal to Na over Nb. And sometimes Na over Nb can also be referred to as the mole ratio. Ca is the concentration of the acid used, Va is the volume of acid, Cb is the concentration of the base, Vb is the volume of base, while Na and Nb is the number of moles of the acid and base respectively, which can also be referred to as mole ratio as earlier said. And this is usually gotten from the chemical equation, a balanced one to be precise. Let's continue. After writing the formula we'll be using, the next thing to do is to write out the values given. This makes the work easier. When solving any calculation of this format, the best thing to do after writing out the formula you want to use is to write out the given values so as to identify the unknown. So here we have Ca to be 0.106 mol per dm cube. Va is given to be 23.40 centimeter cube. Na, from the equation, that's the coefficient of the acid. Na here is 2. For the base, Cb is given to be unknown. Cb is unknown because the question says calculate the molar concentration of the basic solution. That means the molar concentration of the base is unknown. So we have that to be unknown. The volume of the base is given to be 20.00 centimeter cube. NB, number of moles of the base. Here we have NB to be 1. Let's proceed. So Cb is the unknown here. To get Cb, we'll be making Cb the subject of the formula. So we have Cb to be equal to CAVA multiplied by NB divided by VB multiplied by NA. So let's substitute the values. We have Ca to be 0.106 mole per dm cube multiplied by Va 23.40 centimeter cube multiplied by NB, which is 1, divided by VB as 20.00 centimeter cube multiplied by NA, which is 2. So this gives us 2.48 over 40. Our unit, mole per dm cube. Which is equivalent to 0.062. Then the unit, mole per dm cube. And this is our final answer. So Cb here is gotten to be 0.062 mole per dm cube. Hence, we can say that the molar concentration of the basic solution in the acid-base titration experiment is 0.062 mole per dm cube. And that answers the question.